this, where you had a triangle, you had side lengths, and you had to figure out what the theta value was. You place theta 3/5. You're trying to figure that out. You type it in. Well, I'm not worried about what it is, but you're trying to find the angle.
Oh, yeah.
So when you try to find the angle, remember the buttons you press in the calculator, second sine or second cosine of the answer, things like that. You guys were doing that before with non-normal-ish angle values. Okay? You guys were doing that for, you get weird angles. It's no big deal. Obviously, right now, we are not using calculators, which means we have to be able to use things that make sense. We're going to have something land on values that we can duplicate. We're going to have something land within our triangles. Okay? That's the whole idea of understanding how the reference angle stuff works, is how we understand how the 30-60s and the 45-90s work, and so on and so on. So what happens is, when we use inverse trig functions now, there's only going to be, there's for the three trig functions, there's going to be three generic basic rules that we have to follow. Where do we look for them? Okay? So when we get down to it, when we start going through these, get here. Sine values and cosine values are bounded between 1 and -1. Hence why the circle, you can't go beyond that. Then put it away. All right? You can't go beyond that. All right? So you're never going to get a sine value that's greater than 1, you're never going to get a sine value that's less than 1, and so on. But we saw that because your quadrantals did that. Okay? They were bounded in there. So what happens when you start looking for sine values? What we're going to do is we search for sine values between pi over 2, and then we go the other direction to negative pi over 2. The reason why we do that between the first and the fourth quadrant is what happens to your sine values in the second quadrant. Yeah, it's the same value. It's because it's the same, it's the y-coordinate. Y-coordinates are the same in the first and the second quadrants. That's why we have to figure out a way to look for a sine value that's negative. The easiest way to do that is just to go 1 and 4. Okay? So what will happen is, when we search for sine values, we're going to plot circles, or not plot circles, excuse me, we'll draw our angles, we're going to figure out where our triangles lie, and so on. Okay? Again, it's not going to be really difficult, just remembering that this is how that works. These are inclusive of pi over 2 and negative pi over 2, so we're going to be able to use both those values. The reason why I'm saying that is because at tangent, what happened at pi over 2? Remember, it was y over x, it was undefined. Things like that come into play. Okay? So sine, you look for it between pi over 2, negative pi over 2, helps if I put that negative symbol there. Cosine, a little bit different. Cosine values, you actually do go between 0 and pi. Okay? The reason why we go to pi with the cosine values is because those are all obtuse angles, and all those guys become negative value. Okay? Because cosine is negative in the second quadrant. So when we go into these things, if you are searching for an angle that has a cosine value that winds up being negative, your angle will always be obtuse. Whereas sine, and here in a minute, tangent and sine angles are always going to be acute. There's going to be positive or negative. Okay. Again, cosine can't go beyond 1 or less than -1. Those are very simple things that you guys have seen before, so it's not a big deal. The last one then is the tangent. And what happens with tangent is, think about the quadrantal. When you're at pi over 2, when you're at pi over 2 or 3 pi over 2, in this case I'll call it negative pi over 2, they're undefined. That's why I have open dots there. Okay. And that's when we search for these here. So you search for tangent. We just search for tangent this way, between pi over 2 and negative pi over 2. Non-inclusive. Okay, let me go from there. It starts out to sound kind of weird as we're doing these things, but once we put a couple of these problems up, and I show you guys how we set them up and solve for them, this is a lot easier than what you did yesterday, to be honest with you. And you don't believe me. Yeah, you don't trust me. I know. Right away, you're looking at me like, yeah, you're full. Yeah. All right. I think it is because. No, think of it this way. If I'm only being bounded within specific regions to search for angles, how many angles can you really have? You only have a few of them. So if you think about sine is between pi over 2 to negative pi over 2. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 angles. Cosine's the same thing. Change that. There's only 9 of them there. And then tangent is 7 of them. Correct. So there's only 25 total angles you can work with. It's a lot less than what we did yesterday. Because yesterday, you can do it infinitely, because I can always add 2 pi to something, or I can add a pi to something. Okay. So here, what we'll do is this. Oops. It'll look like this. Sine to the -1, remember when we did that? Now, we did that before we did that in the calculator, we hit the second sine, type in decimal, whatever. Now this means to us, what angle has the sine of √3/2? That's what this means when you read this. What angle has the sine of √3/2? Well, is that positive or negative? It's positive. So it's positive, so means it's got to be in the first quadrant. Sine's positive, it goes positive to negative in the fourth, so I have to figure out where does it go in the first quadrant. Well, what is sine in terms of sides? Sine is what over what? Okay, so it's opposite of hypotenuse. You draw it. Theta goes here, because it always does. Your opposite's the √3, your hypotenuse is the 2. What angle has the opposite of √3 and the hypotenuse is 2? It's the 60. So the 60, your answer is pi over 3. Angle has the sine of √3/2. Pi over 3.
Do you want to read it?
Yes. Keep reading. Yes, ma'am. If they're both negative, here's what will happen. Well, tangent, they're not both going to be negative because you're only looking at the first. Yes, sir.
So that's just
Yep.
because 180 divided by 3 is 60. 180 divided by 6 is 130.
What angle has √3/2 for a sine? 60-degree angle. 60-degree angle is pi over 3. Okay. Cosine. What angle has a cosine of 2? What angle has a cosine of 2? What's cosine bounded by? Don't lean on your chair, please. Cosine can, okay, that's what you're searching for, between 0 and pi. Is any value between 0 and pi, is cosine ever equal to 2?
Probably not.
Is cosine ever equal to 2?
No.
What's the maximum can it be? 1. So this is no. Can't be beyond 1. No angles have a cosine value greater than 1. Last time I checked, 2 is greater than 1. Okay? Yeah, C can be used 2. Okay?
Are we going to do all 6? Are we just doing the 3 or are we going to do all 6?
What do you mean?
You just said secant.
You can do secants with all these.
Yeah.
It means the same thing.
Are we going to use it?
Maybe. This one says, what angle has a tangent of -1? So, tangent, where's tangent negative according to the parameters we just talked about?
Fourth quadrant.
It's got to go to the fourth quadrant, so we draw it. So if it's tangent and it's 1, that means that's opposite over adjacent, excuse me. For it to equal 1, those two have to be the same value. Well, convenient, because doesn't that have to happen?
Yes.
Means this is my √2. What angle does that happen with? By 45. But I'm fourth quadrant, and I've dropped it down. And remember, tangents between pi over 2 and negative pi over 2, so my answer would be nope, negative, not pi over 4. Negative pi over 4. Yes. Yes. Yep. Keep everything in radians. Is the rule for searching for tangents between 1 and 4, pi over 2, negative pi over 2.
Pi over 4. Because 45 is
Because it's undefined. It's undefined in pi over 2, negative pi over 2. Can't do it. Okay. Guys, what's that? Thank you. All right. Okay, take a second here. Try those real fast. Try those. Again, draw it. Figure out which triangle you're in. Label. What's that? Radians, please. Yeah, stay in radians, please. The quicker and better, the sooner we keep doing radians, the easier everything else that we do with equations, make your lives easier. Yeah, one of the things we're going to do, like I said, the trigger thing will be on Thursday. Friday we'll start with our identities, which is basically proofs. Like, well, if you start seeing rationalized values, not your radicals always went up in the numerator, because you have opposite over adjacent. If the root 2 is the hypotenuse, that then it had a rationalized value. So how do you unrationalize that? Yeah, a lot of times you have to remember that some of these things are going to give you solutions that are already rationalized. So you have to start thinking in terms of what does it look like unrationalized. So if I've got root 2 over 2, that meant it had to have been 1 over root 2 to start. That's how that would have looked. Okay? Because obviously you don't have a triangle with a root 2 as an adjacent and a 2 as a hypotenuse. You have to think about what that looks like. That'll happen also with the root 3's over 2's. Okay?
So, if it's positive, it's in like firm quadrant.
Yes. Yep. Yeah. Yeah, I mean, this is going to be positive, this is going to be positive, this is going to be positive, this is going to be setting up to be negative, but remember it's cosine, which means it just has to be obtuse. Okay? So, hopefully we got through tangent already. Root 3, it's positive, that means root 3 is my opposite, what has to be my adjacent then? 1. So you have your opposite of root 3, your adjacent of 1. What angle has the opposite of root 3 and adjacent of 1? 60. Your answer then would be pi over 3. Okay. When you did cosine root 2 over 2, that meant it was a rationalized version of 1 over root 2. Again, positive, 1 and a root 2. Well, that has to be 45 to get the root 2's. So your answer is pi over 4. Good. Okay. As you get to what angle has a sine of 1/2, again, it's positive, so it's going to go first quadrant. Opposite is your 1, hypotenuse is the 2. Here's your 1 and your 2. What angle is that? It's got to be your 30, which means your answer is pi over 6. Very good. The cosine one at the end, though, is a little bit weirder, and this is where let me write it out on a separate one. I have cosine. What angle has a cosine of negative 1/2? So, cosine, when you're negative, you have to go second quadrant to search for it. Right? So you plot it, just like we have before. Reference angle. Adjacent is your negative 1. Hypotenuse is your 2. Oops. Which means this is my root 3. So what angle is opposite the root 3? 360. Now remember, this is your reference angle at pi over 3. I'm looking for the angle at the terminal side to be obtuse. My answer is not pi over 3. My answer has to be 2 pi over 3. Okay? My answer has to be 2 pi over 3 because the pi over 3 is my reference. Remember, in order for cosine to work, to get the negative value, that value, the angle, has to be obtuse. Okay? Cosine's the weird one. Okay?
So it's not. You have one. Oh yeah.
The other one, the sines and tangents, since they drop to that fourth quadrant area, they're just saying it's negative pi over 3. If that's okay here. Sine and tangent won't have obtuse angles in this case. Okay? Sine could have a 90, pi over 2, but it's not.
So anytime it's over that, you want to find the angle from.
Because pi over 3, remember the cosine of pi over 3 means, where do I place it? Pi over 3 is in first quadrant. I'm not looking for first quadrant. I'm looking for what one has the negative value, which has to be second quadrant.
Everything starts at 0.
Correct. And that's the weird. You just got to be careful with the cosines that are negative. That's usually where people will go a little weird on. Okay. Okay. What was the other one? Try another one with the cosine real quick. That's what angle has a cosine of negative root 3 over 2? It's kind of the same problem we just did. Yeah. Yeah. Cosine, and that's only if it's negative. If the angle I'm asking you to find is negative. It's the only time you have to worry about it. Okay? This is why we draw angles. This is why we get reference angles. This is why we have to remember our triangles from last year. Everything kind of comes to a head with this whole unit. Okay. So it being negative, it's got to go to the second quadrant. Adjacent's my negative root 3. My hypotenuse is my 2. Here's my 1. This means it's a 30-degree reference. So it's pi over 6. Which means this angle has to be 5 pi over 6. Yep. And cosine's the weird one. It's the only one that has to do that.
Is that what we were doing before?
Yep.
I thought we were finding the actual.
We did, but remember, it's the reference angle gives you that side length. But for that cosine to wind up being negative, it has to be obtuse to come over to it. Okay? What do you got,
So, the cosine has to be obtuse, so you're not finding the angle.
If cosine is negative, that means the angle that you're looking for is obtuse.
Only when it's negative.
Only when it's negative.
So then the secant would be on the bottom, I'm guessing.
If I ask you,
Or the
if it was secant, if I say what's the secant of what would that be? A straight thing one. 2 root 3 over 3. Negative 2 root 3 over 3. So you have to figure out, all right, what is that unrationalize and go backwards off of it. Okay. So you can do that. I mean, I can say what is the, try to do an easy one. What is the cosecant of 2? Okay, cosecant of 2 is hypotenuse over 1 over opposite. So it's, what angle is that? Well, that would have been first quadrant. So it's 1 and a 2, so that's still your 30, so that's your pi over 6. Okay, you're still doing it that way. When you have the reciprocals, you might have to do a little bit of the unrationalizing. Yes, sir?
Wait, what was the specific thing about cosine that you're saying?
If you're looking for a negative cosine angle,
You go around
you have to be an obtuse.
Right.
you're also solving from 0. The angle from 0.
Yep.
It's just the way I think.
What?
Like when I the starting.
Yeah, start the triangle here and go like this. That just helps me find the rest.
Pi over 6 over 6 over 6, yeah. Yep. That's all that is. It's a reference angle, but it's kind of an important thing. I want you guys to work through, I think I got like 8 of these, but then I also have more practice from what you did last night. So I made a sheet real quick, and I wrote out a bunch of the angles for you. We'll go through both of these types of things tomorrow. Those are the 6 and the section, or yeah, the 8 of them that I have, I believe, in this section. PDF is up. Problem numbers are already on the website. I did not scan this one to the calendar. I forgot to get that far. But I'll give you a hard copy. So going through both of those, both sides of these are problems that look exactly like what we did yesterday. It's more practice of them. You'll have to get reference angles, figure out what values you're at, and go from there. That and this. Yep. Yes, sir. Yeah, grab some water.
Zero, one.
Yeah. 0, 1, 1, 0, depending on what it is. So your sine values are your y's, your x values are your cosines, y over x is handled. Done? Alright, so that's 0, 1, right? So cosine 0, cosine 0, sine 1. Tangent is undefined. That's why we kept saying that cosines are, I don't know, you might have heard me say what comes first in the alphabet, x or y. That's the whole point of that. That's why I keep saying it.
I have a question on the units. What was the point of doing the ordered pair of like the pile first? Because we wrote it and I didn't use it, so I was wondering what.
So the order pair for pi over 3, that's just your cosine and sine at 60. Those are your cosine sine values for each one of those order pairs. For each one of the instant line, or not sorry, that's your cosine sine values. So as you go through, if I'm at pi over 6, my cosine would have been root 3 over 2. My sine was 1/2. My order pair was root 3 over 2, 1/2. It's easier just to draw a triangle because then you've been doing these triangle things forever. It's easier. Don't ever try to memorize it in a circle. It's just a waste of time. Trying to solve that. The cosine 45 pi over 6. Right. That's the same thing you just did. Yes. Same thing you just did. You still have to do the job. You have to reference that place. Whatever it's asking for. What's the cosine of that value? Yep. Same thing as those the same problems as homework. Added and subtracted some pi to it.
What do you have for dinner?
French toast.